Hello students, welcome back to my channel Explore Physics, Let's Explore. I hope you all are doing fine. In the previous class, I've explained you about the sign convention for lenses, lens formula, magnification and the power of lenses. Now I'm going to give you a few tips to solve the numerical problems based on lenses, and we are going to take few numerical problems of refractive index as well. So let's start the class. So the tips to solve the numerical problems I'm going to discuss, like I have told you for mirrors, same thing I'm going to talk about convex and concave lenses. I've discussed with you that the principal focus or the images are formed in barring one case, real and inverted to the other side except one case, whereas in concave lens all the images are formed to the same side of the lens. So first, the U is always negative for convex lens. F is always, because to the other side, positive for convex lens, and V is positive except one case, when the object is very close to the lens, then to the same side the image is formed virtual and erect. So at that time only the V will be negative because it's to the same side or opposite to the direction of incident ray. Otherwise, in all the other cases is to the other side, real and inverted. So for convex lens, U is always negative because it's opposite, the direction is opposite to the direction of incident ray. F is always positive. This side of F, they are going to intersect. If you are talking about the parallel rays coming and converging to the focus, so it's to the other side. So F is always positive and V is all positive except one case. This is all about the convex lens. Now let's talk about the concave lens here. For the concave lens, U always negative. So what we have concluded, U is always negative for mirror as well as for lenses. V in this case, V always, the virtual and erect images are formed in front of the lenses, so V is always negative. U and V are always negative for concave lens. F is also negative because we are going to take this F here, so F is negative for the lenses. So for concave lens, so for concave lens, U, V and F always negative, because if you recollect, we have said that the ray appear to go through focal length, not actually goes. So F is always negative. So U, V and F are always negative for concave lenses. So I hope you know it. U always negative for all the lenses and mirror. V positive for convex, F positive for convex, and here U, V and F all are negative for concave lens. If you know this, we are going to take a few numerical, or going to discuss few numerical problems. So let's start that. Alright, so this is the first numerical which we are going to see it here. The first is refractive index of diamond is 2.42. What is the meaning of this statement? So what does it mean? If n is given or mu is given as 2.42, what does it mean? We know that n is equal to C by V. N, or refractive index, is already given to you as 2.42. So 2.42 is equal to C is the speed of light in air or vacuum, that is 3 into 10 to the power 8 meter per second divided by V. So V is the speed of light in this case diamond. So it shows that V is equal to 3 into 10 to the power 8 by 2.42. So what does it mean? It means that the speed of the medium is reduced by 2.42 times that one it shows. And if you just do it, this is 2.42, you know, so approximately 1.23 into 10 to the power 8 meter per second. The speed is coming as 1.23 into 10 to the power 8 meter per second, which is actually 2.42 times lower than the speed of light. So this shows that the speed of light gets lower if our speed is reduced when the light ray goes to diamond, and that's how we found the speed. So it is how much fraction? 2.42 times lesser or lower. So that is the first question. The second question is, find the power of a concave lens of focal length 2 meter. So you have to find the power of a lens of a concave lens of focal length. You have been given focal length as 2 meter. So we know P is equal to 1 upon F is equal to 1. If it's in meters, then it is 1, and F is 2. So 1 by 2 is 0.5. Power is in diameter, so 0.5 D. So what is the power of the lens? The question, find the power of a concave lens of focal length 2 meter. So it is 1 upon F, and F for concave lens is always negative. So 1 upon minus 2. So it is minus 0.5 D. That is the answer solution for question 2. Now the question 3 says, I hope it's clear to you children. Question 3 says, find the focal length of a lens of power minus 2D. So the focal length you have to find, and you have been given the power as minus 2D, somewhat the same which we have done that time. So find the power of a lens. So power, same thing we have done, no? Find the focal length, sorry. So power is equal to 1 upon F. That implies F is equal to 1 upon P. So 1 upon P was given as minus 2. So minus 0.5. Minus shows that it's a concave lens. So that is the what type of lens? What type of lens is this? It's a concave lens. Now the next fourth question is, so I can write it's a concave lens. Now let's go to question number 4 and see what does it say. Question number 4 is, a doctor has prescribed a corrective lens of power plus 1.5 D. So P is given to you as plus 1.5 D. Find the focal length of the lens. So you have to find F. Is the prescribed lens diverging or converging? So because we already know that it is plus, so it's a convex lens, it's a converging lens. Find the find the focal length, is the lens or converging or diverging. So same thing, we are going to say that P is equal to 1 upon F. So therefore F is equal to 1 upon P. 1 upon P is given to 1.5. So here 15, 6, so 0.666 bar or 0.667 I can say, or 0.67 D. So this is the power, sorry, this is the F. So you have, sorry, this is meter you are finding. the focal length. So it is 0.667 or 0.67 meter. It's a converging or diverging lens because it's plus. They have asked you, is it diverging or converging? Because f is in plus, so it is a converging lens or a convex lens. Now I hope it's clear to you. Same formula we are using, P is equal to 1 upon F or F is equal to 1 upon P. If F is in meters, then we are going to take 1 upon F. If F is in centimeters, we are going to take 100 upon F. That is the only thing, is the only difference in the formula when we are taking in meters or in centimeters. Now the next question, question 5 says, a light enters from air to glass having refractive index 1.50. So mu is given to you as 1.50, no ratio, so no unit. Find the focal length of the lens. So you have to find, sorry. Light enters from air to glass having refractive index 1.50. What is the speed of light in the glass? Easy. So you have to find speed of light in the glass, the speed of light in vacuum they have already given. So given to us that it is 3 into 10 to the power 8 meter per second. So you have to find V. So mu or N is equal to C by V. That implies V is equal to C by nu. C 3 into 10 to the power 8 meter per second. We already know mu they have given as 1.50. So if these they have gone, so it is 100. So it is 300. So I'll just write it 300 upon 150 into 10 to the power 8. 152. So therefore V is equal to 2 into 10 to the power 8 meter per second. So this is our answer. V is equal to 2 into 10 to the power 8 meter per second. Right. This is the fifth question. Simple. N is equal to CV or mu is equal to C by V. We have taken. From that we found that V is equal to C by nu. We already know all the things. So that's why V is equal to 2 into 10 to the power 8 meters per second. We'll take question number 6. So question number 6 is, this is question number 6. A concave lens of focal length 15 centimeters. So F is given to you as 15 centimeter. Forms an image 10 centimeter from the lens. So you've been given focal length. Forms an image. So you know V is equal to 10 centimeter from the lens. How far is the object placed from the lens? So you should know what is E. You have to find what is U or what is U. Yeah, what is the position of object. Draw the ray diagram. So we have to draw the ray diagram also. Now F is, you know the formula, F 1 upon F is equal to 1 upon V minus 1 upon U. That implies that 1 upon U is equal to 1 upon V minus 1 upon F. 1 upon U is equal to 1 upon V minus 1 upon F. V is given to you 10. V is 10. This is a concave lens. U is always negative, and for the case of concave lens, V is minus because it's always to the same side. So here 1 upon minus 10 minus 1 upon F. F is also negative here. So minus F is 15. So this is minus 15 because it's a concave lens. So here we have 1 upon U is equal to, therefore 1 upon U is equal to 1 upon minus 1 upon 10 plus 1 upon 15. So both we have same as 30 minus 3 plus 15 twos are. So here we have minus 1 upon 30, or u is equal to minus 30 centimeter. So we have u is equal to minus 30 centimeter. 1 upon u is minus 1 upon 30. So u is equal to minus 30. You have to just draw the ray diagram. So we know that V is equal to this much. So I hope it's clear to you. 1 upon F is equal to 1 upon V minus 1 upon U. From here, from the formula only I have taken 1 upon U is equal to 1 upon V minus F. For concave lens, V and F are always negative. So easy for us to understand. We found that 1 upon U is equal to minus 30, or U is equal to minus 30. 1 upon U is equal to minus 1 by 30. So U is equal to minus 30. Now you have to draw the ray diagram. So remember, now we have to draw the ray diagram is clear to us. It's coming as minus 30 centimeter. So now if you see, U is minus 30, F is minus 15. So first I'll erase all these things and then we'll draw the ray diagram. So here we have, it's a concave lens. Yeah, a concave lens. So a concave lens always make easy for to make the diagram for convex lens, because we have here, how you're going to show, I'll tell you, the principal axis, everything is here to this side. So F is, say this is F and this is 2F, F1 or 2F1 also you can take. Now F is minus 15, so the 2F1 will be minus 30, and if you see that U is also coming as minus 30, so F was minus 15, U was minus 30, so it means the object is placed at the center of curvature only. Why? Because this from O to this F distance is given to you as 15 centimeter. That's how you're going to write in the diagram also. F is equal to 15 centimeter, and U is here. U is, we calculated that U is equal to minus 30 centimeter and V is equal to minus 10 centimeters. So it is 15. Somewhere here the image is formed. Somewhere here the image is formed. So you already know that we will be taking one ray coming from the object, which diverges like this. So this is one ray, and the second ray I'm going to take which goes through O and comes back in the same direction. So I have taken this as the ray which retraces its path. So here we have, erased a bit. So this was F, our F was here. So somewhere here wherever they intersect, so I am going to produce it backwards. So here they are going to intersect. Where they are going to intersect, the image will be formed there. So where one ray I have taken which is parallel to principal axis, diverges like this, and it appears that it is coming, if you produce it backwards, so it is going through F. Wherever they intersect, the image is formed here. Hope it's clear to you. So this was 15 centimeter. So this is F. One ray I have taken which is going parallel to principal axis. After refraction goes like this. If you produce it backward, it appears to go or crosses through F. So here I have taken F. And then one ray passes through O and retraces its path or comes back in the same way. And here the 2F is here. So F is minus 15. So 2F, or the radius of curvature, will be minus 30. The image also, the object is also placed because we calculated object at 30 centimeter. So this will be the diagram for concave. For concave mirror, almost this is the diagram. You have to take only these two rays, just produce it backward, it should go through F. So this is the ray diagram for question number 6. I hope it's clear to you. Now we are going to take the 7th question, and what is that? An object 5 centimeter in length. So h is given to you as 5 centimeter. You may also take it instead of h, you may take it as O also, that's height of object. 5 length is held 25 centimeter from a converging lens. So from a converging lens, U is always negative as I told you. So minus 25 centimeter U is given from a converging lens. So U is always negative for all the lenses. Of focal length 10 centimeter. Here F, because it's a converging lens, so plus 10 centimeter for convex lens, always positive F. Find the position, size and nature of the image formed. You have to find the position, size and nature of the image formed. We have got everything here. So 1 upon F, we are going to use the lens formula, is equal to 1 upon V minus 1 upon U. Or from here, that implies that, what do we have to find? V. 1 upon V is equal to 1 upon F plus 1 upon U. 1 upon F is given as 10 plus 1 upon U, that is 1 upon minus 25. Minus 25 here. So I may write that 1 upon V is equal to, therefore 1 upon V is equal to 1 upon 10 minus 1 upon 25. So here we have 25 and 50. We take 50. Yeah. So here 5 minus 2. So we have 3 by 50, or V is equal to 50 by 3. 50 by 3. So we have 3 ones are 3. 3 6 are 18. 16.666 or 16.67, whichever you can take. 16.666 bar, that is 0.6 bar centimeter, or 16.7, whatever you can take. So you have to find the M also. Now M is equal to V by U. So V is how much? 16 plus, it was plus. So 16.7 I am taking here. U was minus 25. So M will be some 0.668. 0.668, that is our M. So M we know. So it is 0.668 times that of the object. So we can find that H dash is equal to, let's write it here. So I'll write it here. We can also use this formula, M is equal to H dash by H, or H dash is equal to H, M into H is equal to, M was minus 0.6868. I'm taking 67 here. I may just write it approximately equal to minus 0.67. Here I'm writing this. So into H was 5. So into 5, that is minus 3.35 centimeter. So M, or the height of the image is minus 3.35. Correct. So we have this. So minus sign shows this H dash is equal to minus 3.35. This minus sign shows that it is a real and inverted image. 3.35 centimeter, it's smaller than the object because object's height was 5, image height is 3.35. So this is the solution for question number 7. I'm going to take one more numerical. I hope this is clear to you. You'll be using the formula for lenses, that is a lens formula. 1 upon f is equal to 1 upon v minus 1 upon u, and m is equal to h dash by h or is equal to v by u. So you should know, children, the sign convention, what will be the sign for u, v and f. The next question, 8th question I'm going to take. What does it say? A convex lens forms a real and inverted image of a needle at a distance of 50 centimeter from it. So v is given to you as 50 centimeter plus 50 because a converging lens, convex lens they have told. Where is the needle placed in front of a convex lens? So you have to find u in front of, if the image is, where is the question gone? If the image is equal to the size of the object. So h dash is equal to h they have given. Also find the power of the lens. You have to find the power of the lens as well. So that you have to find f. So when they have already given you that the size is the same sized image, so naturally the f is, you have to find whatever the f, and the image will be formed. You have to find, so u will be placed at 2f only. Remember, when the object is placed at center of curvature or at 2f, the image by a convex lens is formed at 2f only, rear, inverted and same size. So this is the same case we are talking about. Now you have to also find the power of the lens. So you have to find f first. So 1 upon f is equal to 1 upon v minus 1 upon u is equal to, v is, they have given 50. So u also will be 50. So u will be minus 50 centimeter here because they have given same size thing. So minus 50 because u is always negative. So we have here 1 upon 50 plus 1 upon 50 is equal to 2 upon 50. So 1 upon f is equal to 2 upon 50. So f is equal to 50 by 2, that is 25 centimeter. So focal length is 25 centimeter. You have to find the focal length. The image is equal to, say, also find the, now you have to find the power. Now P is equal to 1 upon f. If is in centimeter, here we have taken, it's given, focal length is given in centimeter. So we have 100. P is equal to 1 upon f if f is in meters. We are going to take 100 upon f. So 100, f is 25. So P is 4D. Plus or minus? Plus because it's a converging lens. So everywhere we have plus, plus, plus. So f is plus 4D. Sorry, power is plus 4D. So I've taken almost all the numerical based on different positions of object. I hope it's clear to you. Do like and subscribe my channel if you like the content. Stay healthy, stay safe, and a very big thank you to you all.